Okay, it seems scientists have come across a strange object in space, and they're not sure if it's a star or a planet. What we do know is that it's located 1,400 light-years away from us, and it makes us question what we thought we knew about the universe. Let me explain the dilemma here. We can tell if something is a star or a planet by considering the object's mass or the amount of stuff it has. Stars have a lot of mass, which gives them strong gravity that squeezes them tightly. Squeezing creates high temperatures inside them, causing them to shine brightly. Planets have less mass, so their gravity is weaker. They don't experience the same squeezing or high temperatures as stars. Instead, planets shine because they reflect the light from their stars, like our beautiful Earth does with our Sun, too. And this weirdo falls somewhere in between, since we consider it a brown dwarf. That's a special type of big, gaseous protostars. Brown dwarfs are usually like Jupiter in terms of their atmosphere, but they are much larger in size, about 13 to 80 times. If a brown dwarf has more than 80 times the mass of Jupiter, it can start burning regular hydrogen, just like a star. That's what usually makes stars shine brightly. But normally, brown dwarfs are not as hot as stars. Their inability to burn hydrogen has even earned them the nickname of failed stars. They burn at around 4,000 degrees Fahrenheit, which is cooler than most stars. But this object defies the norm. Its temperature measures an incredible 13,900 degrees Fahrenheit. Now let's put that into perspective. The hottest day in history was reported to happen in Death Valley, California, more than 100 years ago, with a temperature of 134 degrees Fahrenheit. People back then must have felt like they were melting along with everything around them. Now imagine getting closer to the Sun, like taking a trip to Venus. Venus can reach insane temperatures of 860 degrees. It's not only about the distance, though. Mercury is the planet closest to the Sun, but it's still colder than Venus. Venus is extremely hot due to the greenhouse effect. Did you know that Venus could have been a delightful place to live a long time ago? Or at least be home to any form of life. But at some point, it started to trap carbon dioxide and eventually created this thick, smoggy oven that doesn't release heat. And that's why it's so hard to explore. The longest a probe managed to last on Venus was 2 hours. But hey, that's longer than I can do at work, and then I melt. So yeah, then you get to the Sun. Its surface burns at an incredible 9,930 degrees Fahrenheit. And what's fascinating is that this weird brown star we're talking about is hotter than that. I mean, it's not hotter than the Sun's core, whose temperatures go up to 27 million degrees, but it's still very impressive and unusual for a brown dwarf to be this hot. At least, that's what everyone thought until they realized why it was happening. The brown dwarf is remarkably close to another star that falls into the category of white dwarfs. They're so close to each other that our mysterious star makes one orbit around its white dwarf friend in just 2.3 hours. Woo! How old we'd be over there! Since they're this close, they're tidally locked like our Moon and Earth. That means one side of this brown dwarf always faces the white dwarf, and the other side is forever in darkness. Because of all this, our brown dwarf is superheated on one side only. So its day side is what got us confused. While the temperature on the night side is what you would expect from a brown dwarf. But these extreme conditions won't last long. Such a hot temperature makes the molecules in the dwarf's atmosphere break apart into individual atoms. And while its molecules are falling apart, this brown dwarf is slowly disappearing. And if you think this brown dwarf is hot, what would you say about Eta Carinae? It's a star located about 7,500 light-years away from Earth, and it belongs to an elite group of stars we call luminous blue variables. One astronomer first noticed it in the 17th century, but back then, it was just a regular medium-bright star. Almost 200 years later, another astronomer was observing it. But this time, it was a very bright star, one of the brightest ones in the sky. A few years later, it reached the highest level of brightness in a big event called the Great Eruption. When it happened, the star could be easily seen in the night sky. It released so much light, as much as is emitted in a supernova explosion. It remained like that for a couple of years, which is not what usually happens with exploding stars. After the party reached its peak, the star decided it was time to leave. It's still hesitating though, so it's still alive but dimmer than before. There's a nebula around Eta Carinae too. It is a shell made of gas and dust that formed during the Great Eruption. It even blocks some of the star's light. Eta Carinae is a binary star system. That means there are two stars that orbit around each other. One component has a temperature of about 26,500 degrees and the other 62,500 degrees. The main star in the Eta Carinae system, which is the more massive of the two, is 100 times heavier than our Sun. Because of its enormous mass, scientists predict that this star may eventually explode in a powerful event known as a supernova. But not for another several thousand years. So, by now, you might have already guessed what the hottest thing in the universe is. Ta-da! A supernova. The supernova is what tells us that the life of a star has ended. We're talking about the most powerful explosions in space. They happen when a star that's between 8 and 40 times more massive than our Sun flops. Its core can no longer create enough energy through a process called fusion, so the star can't even handle its own gravity. It's like a stellar burnout, too much work a star can't handle, and its core just collapses. During a supernova, the temperatures in the star's core can get 6,000 times higher than in the core of the Sun. Or sometimes, a specific type of star called a white dwarf suddenly restarts its nuclear fusion, and bam, you get a supernova again. Kepler's supernova happened at the beginning of the 17th century, and it was the last really big supernova event we directly observed from Earth. On average, supernovas in our galaxy happen 3 times every century. I mean, we got a smaller supernova in 1987 too, when a blue supergiant exploded in one of the Milky Way's satellite galaxies, which we know as the Large Magellanic Cloud. This explosion was so strong, people could even observe it with the unaided eye, even though it was incredibly far, 168,000 light-years away from our home planet. What a topic for summer days, huh? But check this out. We can also talk about the hottest thing people have ever created, made in a surprising place, Switzerland. Nah, we're not talking about a super hot chocolate. A group of scientists there created a subatomic soup called a quark gluon plasma. In this experiment, the temperature got 250,000 times as hot as the Sun's core. The purpose of this experiment was to recreate the conditions that existed shortly after the Big Bang, when the universe was still in a state of chaos. Okay, let's get even more extreme. In theory, things can get even hotter. Have you heard of the Planck temperature? It's an insanely hot temperature with numbers so high we can't even imagine. A supernova is like tepid tea compared to this madness. And who even knows what the matter does at these temperatures? Okay, I'm done. Now we take you back to your regular universe. Bye now.
Check out this interstellar showstopper. Shadows doing a little dance in space have spilled the beans on a mind-boggling secret about our solar system's origins. There's a star, called TWW Hydrae, that's playing host to some mischievous disks that are out of sync, spinning at slightly wonky angles. But what's causing this celestial chaos? Well, it seems like a bunch of baby planets are misbehaving, tugging at the disks with their gravity and throwing everything off balance. Hold on tight, because things are about to get even more interesting. This star is a real newbie in the cosmic neighborhood at just 8 million years old. Yep, that's practically a cosmic toddler compared to the ancient Sun, which has been around for a whopping 4.6 billion years. This new start hasn't even started its hydrogen-burning season yet. it's still in the process of growing and compacting under its own gravitational pull. Think of it as the sun's younger doppelganger. Here's the lowdown on how stars like TWW Hydrae get their groove on. They gather cosmic dust and gas from their surroundings, which forms a swirling disk around them. This disk is like a cosmic buffet for planet formation. Little specks of matter come together, forming bigger and bigger clumps that eventually collide and grow into full-fledged planets. Since they're born from a flat disk, these planets usually end up orbiting their star in a neat, flat plane. Now, our new star has struck gold with its unique orientation. We're lucky enough to have a front-row seat to this cosmic construction site because we can see the disk face on. And guess what? It looks a lot like our solar system. This gives us a chance to uncover some juicy secrets about our own planetary origins. Back in 2017, eagle-eyed astronomers noticed a shadow making its way around this new star's disk. It completed a full rotation every 16 years. Initially, they thought this shadow might be evidence of a sneaky young planet forming within the disk, causing parts of it to wobble in different directions. Fast forward to 2021, and things took an unexpected twist. The shadow did something totally unexpected, leaving everyone scratching their heads. Hold your horses, though. The savvy team of astronomers didn't give up easily. They put their thinking caps on and came up with a few possible explanations. After extensive modeling, they hit the jackpot. It turns out not just one, but two wobbly disks were at play, casting shadows on a third outer disk. This suggests the existence of a second young planet, making it a cosmic double feature. Imagine these two planets zooming around, one trying to outpace the other, like a pair of racing cars. The data suggests that the first disk is about 5 to 6 astronomical units from the star, while the second disk is around 6 to 7 astronomical units away. For reference, our mighty Jupiter orbits the Sun at a distance of 5.2 astronomical units. So, it's like a cosmic game of tag with the planets influencing each other's orbits. As these planetary misfits go about their orbits, their gravitational interplay causes the disks to tilt slightly with respect to one another. This creates shadows that dim the outer regions of the disk. Oh, and by the way, this totally matches our own solar system vibe. Why? Because some of the planets in our own solar system are rebels too, and have orbital inclinations that vary by up to 7 degrees. I'm looking at you, Mercury. Or a whopping 17 degrees if you count our dear friend Pluto. Who knows? If we continue researching this new star, it might just spill the beans on how our own solar system's got its funky orbital inclinations. How exactly do we define our solar system, though? It's like a celestial neighborhood with 8 funky planets happily orbiting our sun. In order of proximity to the Sun, we have Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Oh, and we can't forget Pluto, our little dwarf planet friend who used to be part of the Planet Club. Our solar system is way more than just the sum of its planets. It's like a fantastical mashup of asteroids, comets, stars, moons, and a whole bunch of other spacey stuff that makes our cosmic home truly enchanting. Contrary to popular belief, the hottest planet isn't the one getting all cozy next to the Sun. Nope. It's Venus, the second closest planet. How come, you might ask? Well, Venus is scorching because it has an ultra-thick atmosphere. It's basically like it's wearing 100 layers of sweaters. When sunlight pierces through this super dense atmosphere, it turns Venus into a fiery furnace. We've also got some rocks on Earth that are like interplanetary tourists from Mars. Can you believe it? Scientists have found these rocks here, and they're chock full of the same gassy goodness found on the red planet. How did they get here? The most plausible scenario is that Mars sent a souvenir package through an asteroid crash or volcanic fireworks show. Our planet is also the ultimate chemistry whiz. Sure, other planets have bits and pieces of the elements we have, but we've got the whole shebang. Iron, oxygen, silicon, sulfur, magnesium, sodium, nickel, calcium, aluminum, if you can name it, we most likely have it here somewhere. Other planets are like, hey, we're mostly rock with helium and hydrogen, but we're here with our unique blend of interstellar awesomeness. Jupiter, however, the heavyweight champ of our solar system, has a never-ending party happening in its atmosphere. It's called the Great Red Spot, and it's been swirling with hurricane-like intensity for more than 300 years. This stormy event boasts extremely powerful winds, reaching a blazing 270 miles per hour. Oh, and by the way, this colossal storm is more than twice the size of our entire Earth. Neptune, on the other hand, knows how to make an entrance. It's got the fastest wind speeds in the solar system, zipping around at more than 1,200 miles per hour. Just like Jupiter and Saturn, Neptune actually produces more energy than it gets from the sun. As it turns out, Neptune's energy comes from its core, and that's what powers its super-duper strong winds on the surface. Now you might be wondering, how does Neptune manage to keep all that energy to itself? Well, it's all thanks to a special blanket of methane gas, which acts like a cosmic snuggie. This snuggie, or rather greenhouse gas, traps the heat and keeps it cozy on the planet. If Neptune were a bit more like Uranus, which is a bit of a slacker in the energy department, all that heat would have gone on a space vacation ages ago. Despite the chilly temperatures, Neptune doesn't let it bring down its funky style. It radiates a whopping 2.7 times more heat than it receives from the sun. It's like Neptune saying, "Hey sun, you're cool, but I've got enough heat to make my winds wild and crazy." Space isn't as far away as you might imagine. The Kármán line, which is approximately 62 miles above Earth, is like the official starting point of space. If you could drive your car straight up into the sky, you'd actually reach that mark in less than an hour. That's even quicker than some people's daily commute. As it turns out, our solar system is actually already halfway through its estimated life cycle. Scientists estimate that our solar system is around 4.6 billion years old, and it's expected to keep going strong for another 5 billion years. We've still got a lot of time left in this celestial ride. In the meantime, the Sun, our fiery superstar, will keep trying to pull the planets towards it. Talk about being clingy. Gravity on the Sun is so powerful that it's constantly exerting its pull. But don't worry, the planets are not just passive participants. They're like determined tug-of-war players, pulling in the opposite direction and keeping a fine balance. As a result, the planets end up kind of floating in the middle. It's no wonder the Sun has so much power around here. The mass of the Sun is mind-blowingly huge. In fact, the Sun's mass is around 330,000 times that of our beloved Earth, and get this, it accounts for over 99% of the total mass in our solar system.
Stargazers, come up here, because I have exciting news. Astronomers have just completed the full mapping of 2 pairs of stars outside our Milky Way galaxy that are chowing down on their stellar neighbors. Not only does it give us a better understanding of stars in general, but it can also help us measure distance in the night sky. Did you know that more than half of the stars in our Milky Way are paired? And while it's unlikely that other galaxies have a significant number of binary stars too, they're usually too faint to see. But these so-called symbiotic stars, where one star consumes the other, are extremely bright and easier to observe. And, according to scientists, measuring the orbits of these symbiotic star systems is an essential step towards learning whether other galaxies create binary stars like those in our Milky Way. Now, let's get down to the nitty-gritty. A pair of stars may be born together, but due to their masses, they age differently. The more massive one burns through its material faster, reaching the end of its lifetime first, and leaves behind a compact white dwarf. White dwarfs are small and dim, but can pack the mass of the Sun into an object the size of Earth. If close enough, their gravity can pull material from their companion, creating a signal that astronomers can identify from far away. Draco C1 and Lynn 358 are the symbiotic stars that have been fully mapped. The stars in Draco C1 take roughly 3 Earth years to orbit one another, while Lynn 358's components take just over 2. These are the first full orbital measurements of any symbiotic star system outside the Milky Way. The new measurements will help astronomers better understand star formations in other galaxies. In some symbiotic stars, the white dwarf can slurp enough material from its companion that it explodes in a supernova. These supernovae are incredibly bright and can be seen across the universe. They all start out with the same brightness for a nearby observer, making them like a sort of standard candle for measuring the universe. While Draco C1 and Lynn 358 are unlikely to explode as supernovae anytime soon, understanding how they work can provide us with a better understanding of how these standard candles evolved. If you're here to complete your knowledge of weird stars in the universe, don't be disappointed. We're not finished just yet. Have you ever wondered about the biggest stars in the universe? Scientists have recently discovered a gigantic star called WOH G64. This bad boy is located about 9,500 light-years away from Earth and is truly out of this world. It's about 1,700 times larger than our Sun, which means if it were in our solar system, it would reach past Jupiter's orbit. There's more. WOH G64 isn't just massive, it's also super bright. It's what scientists call a red supergiant, and it shines with a brightness of about 340,000 times that of our Sun. If you're thinking about getting a tan from this star, think again though. It's way too far away for that. How does a star like WOH G64 even form, you might wonder? Well, it starts out like any other star. A cloud of gas and dust collapses under its gravity and starts to heat up. Eventually, the temperature becomes hot enough in the core of the cloud to ignite nuclear fusion, and a star is born. But WOH G64 didn't stop there. It kept devouring more and more gas and dust, growing larger and larger. This process continued until it became the giant we know today. As fascinating as WOH G64 is, it's not the only big star out there. There are others, like Vega Canis Majoris, which was once thought to be the biggest star until WOH G64 stole the show. Vega Canis Majoris is still a force to be reckoned with, though. It's about 1,400 times larger than our Sun, and located about 5,000 light-years away from us. But here's the kicker. Stars like WOH G64 and Vega Canis Majoris aren't even the biggest things in the universe, not by a long shot. There are objects called hypergiants that make these stars look like ants in comparison. One such hypergiant is Stephenson 218, located about 20,000 light-years away. It's about 2,150 times larger than our Sun, and shines with the brightness of 7 million suns. And just when you thought things couldn't get any crazier, there's a mysterious object called the Great Attractor that's pulling everything in our local group of galaxies towards it. We don't know what it is or what's causing it, but one theory is that it's a massive cluster of hypergiants. We'd be minuscule in comparison. The next star is so metal, it's practically headbanging all the time. Jokes aside, scientists have discovered a star that's called a heavy metal subdwarf. Now that's a band name. It's a type of star that's seriously heavy metal. This star has more metal in its composition than any other star we've seen before. Such stars are said to contain metal elements like iron, nickel, and chromium. This heavy metal subdwarf has about 10,000 times more iron than our Sun. In their discovery, astronomers used a technique called spectroscopy, which involves analyzing the light that comes from the star to determine what elements it's made of. By looking at the spectrum of light, scientists were able to see that this star had an unusual amount of metal in its composition. There's more. This heavy metal subdwarf isn't just a regular star with a lot of metal. It's also really weird in other ways. For one thing, it's smaller and cooler than our Sun. And for another, it's really old. We're talking about a star that's been around for almost as long as the universe itself. What does this all mean? Well, scientists are hoping that by studying this heavy metal subdwarf, they can learn more about the early universe. Since this star is so old that it was around when the universe was just beginning to form, it's seen a lot of stuff. By studying its composition and characteristics, scientists can get a better understanding of what the universe was like in its early days. This next star is one of the coolest things in outer space. Her name is Vega, and it's one of the brightest stars in the night sky. Some recognize it as the shiny point of light in the constellation Lyra. And get this, it's only about 25 light-years away from us. which in astronomical terms is practically next door. Scientists have been studying Vega for a long time, and they've learned some pretty interesting things. For starters, Vega is a young star, only a few 100 million years old. That might sound like a long time, but compared to our Sun, which is around 4.6 billion years old, Vega is practically a newborn. Vega is also a very hot star, with a surface temperature of around 17,000 degrees Fahrenheit. To put that into perspective, the surface of our Sun is only about 10,000 degrees Fahrenheit. So if you think it's hot outside today, just be glad you're not hanging out on Vega. Another interesting thing about this star is that it's surrounded by a disk of dust and gas. This disk is called a debris disk because it's made up of leftover material from when the star formed. Scientists think that this debris disk is similar to the one that surrounded our solar system when it was young. Vega is also a source of cosmic rays. These rays are high-energy particles that zip around space at incredible speeds. They're made up of protons, electrons, and other particles, and scientists aren't exactly sure where they come from. But they do know that Vega is one of the places where cosmic rays originate. But wait, there's more! Vega is also a famous star in pop culture. It's been used in a lot of movies and books as a source of inspiration, mostly because of its brightness and cool features.
The Sun isn't technically the center of our solar system. It's in a space called the Barycenter. It depends on which planet you're standing in. The Barycenter is usually closest to the object with the greater mass. So, since we're on Earth, the true center of the solar system is the Sun, but not the center of it. With respect to Jupiter, the Barycenter is actually outside the Sun's surface. Jupiter is 318 times bigger than Earth, so the balance is different. The planets don't really revolve around the Sun, but around their common center of mass. Imagine balancing a pencil on the tip of your finger. You'd have to place it right in the center so that it doesn't tip on each side. Because the pencil has its mass equally distributed, it's easy to assume that everything balances its way like that, especially in outer space. But try balancing a hammer on the tip of your toe. Chances are you'll walk out of here with a broken toe. Its true Barycenter is close to the hammerhead rather than the actual center where you'd grip it. Earth and the Sun's Barycenter is like that hammer. The center of mass is more or less in the center of the object. Realistically, if the Sun were to rotate around Earth, then our little blue planet would have to be just as big as the Sun, or bigger. We can't disregard the other planets in our solar system, which means they all will have to rotate around us as well. But in the ancient days, bright minds always thought everything revolved around the Earth. They called this the geocentric model, and this made sense to them because it looked like everything above us was spinning around us. The Sun and the Moon played vital roles in human history, and we didn't feel insignificant in the universe until way later on. In ancient Greece and the Middle Ages, the big brains used the geocentric model to study space. It wasn't until the 16th century that that model changed. Back in those times, they couldn't even imagine that everything revolved around the Sun, and they didn't have the knowledge to back any of this up. The Earth can't be the center of the solar system because it's not large enough for the job. For the conditions to suit the enormous size, life would have evolved differently. We'd probably be less dependent on oxygen. Some animals, like whales and dolphins, can stay for hours without taking a single breath. They can even sleep underwater. So the humans of the sun-sized Earth would have specialized lungs and wouldn't need to constantly be taking in air. It means that the plant life would be limited, with just a few shrubs here and there. There are trillions of trees around the world, but the main contributor to producing oxygen is the algae in the ocean. With such vast real estate of oceans and seas, the algae sitting on top are pumping out the air we breathe. Oxygen wouldn't be so abundant on this planet, but our breathing mechanisms might rely on carbon dioxide, another common gas found on other planets. If the planet is hot, then water will be scarce. We would only find it on certain parts of the planet, like mountaintops. The ground would be too scorched for anything to survive in properly. We can forget about seasons as well. The Sun is currently just large enough to give us what we need. But since the Earth would be so large, and the Sun would be another celestial body emanating heat, we'd always feel like we're inside a microwave. The days and nights will be different, and not much precipitation will happen. With so much heat produced in the core, earthquakes and volcanoes would likely erupt all the time. The surface would practically be a scorching plain of red magma floating around. This would be the true red planet. But if we had the same landscape like on Earth, living somewhere near the mountains could save you. The mountains would still be embedded in the core, but it would be better than staying on the ground. Some of the mountain peaks could even be 100 times taller than Mount Everest. The canyons could be so deep that the Mariana Trench would feel just like a little rupture. Animals would also behave and look different. Cold-blooded animals would have to soak up as little sun as possible so they don't burn. Animals would have to rely on migration to find water in distant lands. Birds can fly for hundreds of miles for migration season, so we'd probably see certain sleek-looking birds speeding through the air. But because gravity would be so strong on the colossal-sized Earth, the flying animals would need thinner bones and a thinner core just to take flight. The real survivors would be the microorganisms. They can live in extreme temperatures and pressures and can live without oxygen for a good while. The nights would be dark since there wouldn't be any moon to reflect the sunlight. The moon would most probably be on the opposite side of where the sun is shining, so it would forever be a floating ball in the sky. The Earth's rotational speed is the fastest at the equator, so if all the planets and the sun rotated around us, then our rotation wouldn't be so significant. New weather patterns wouldn't be good for crops. Humans would have evolved differently from what we are like now. We'd probably be shorter and stockier since gravity is so strong. And because of the soaring temperatures, we'd probably live in caves all around the world. The strongest ones would have migrated to the mountains. We'd probably have the same evolutionary path as we do now, but other physical features might be different. Our pigment would likely look different to combat the heat. The desert fox has large ears for hearing out predators and for cooling itself down in the scorching desert heat. It's possible that we would also have bigger ears than what we have now for the latter reason. We'd be a lot stronger than we are, and our bones would be thick and tough to break. Gravity is one of the key components to developing our bone density and muscle mass. This means we would unlikely need tools for hunting. This would have delayed the Bronze Age and modern civilization as we know it. With little vegetation, standing upright wouldn't be so necessary to find predators around us. We wouldn't be the fastest runners either, but we'd be strong enough to fight off a pack of strange-looking wolves. And if the Earth was supersized, then it's possible that multiple species of humans would be roaming the land in isolated areas. Some human species would grow and evolve into the intelligent thinkers of today, but some would remain the same. And some creatures from the past would still be around, unchanged. Sharks would have been around since the dinosaurs era. They wouldn't have to change their form or adapt because of their dominance. Other animals would remain the same because of their isolation. The Galapagos Island hosts some unique animals because they've been alone for so long. Without proper predators constantly lurking around them, they don't fear humans. The new mega-sized Earth would have areas as large as Asia filled with isolated animals that could remain the exact same as when they first appeared. The human species of those regions would also remain the same, since they wouldn't have moved or experimented with anything. Their diet would remain the same, and they would get used to the climate they're in. Technology would also have flourished differently in various parts of the planet. With some areas in complete isolation, they wouldn't have access to new gadgets and inventions. It would be like living on a planet with different eras in the present day. Other areas would be so advanced, they might even be flying themselves outside the planet in search of truth and answers. Our gravity is good enough for us to live properly and develop life, but if we pumped up our size to that of Jupiter, then gravity would crush us. And being the size of the Sun, Earth wouldn't even be a planet, but a brown dwarf, and would constantly be burning until it became a new sun. As of now, Earth is so small in our universe that we're practically like a grain of sand in the desert. On a cosmic level, we're an insignificant contribution to this universe.
Locating the North Star is quite easy on a clear night. The only thing you need to do is find the Big Dipper. Those two stars on the end of the Dipper's cup point the way to the North Star. See? It's the tip of the handle of the Little Dipper, or the tail of the Little Bear. It's in the constellation Ursa Minor, over there. People have been watching the North Star for centuries. This bright star is also known as Polaris. It's situated almost directly over our planet's North Pole, which makes it a great landmark for a traveler without a compass, or a GPS on their smartphone. It's also Earth's closest Cepheid. That's what we call a star that pulses regularly in brightness and diameter. Polaris is also part of a binary system of two stars. It's got a dimmer sister. It's known as Polaris B. You can actually see it circling the North Stars from Earth. But the more astronomers watch Polaris, the less they understand. The problem is, no one can agree on how big or distant the star is. Scientists have several ways to estimate the mass, age, and distance of a star like Polaris. One method is called the stellar evolution method. After studying the brightness, color, and rate of pulsation of a star, experts use this data to figure out how big or bright it is, as well as what stage of life it's in. Once these details are clear, it's not hard to find out how far a star actually is. It's simple math once you know the luminosity of a star in real life and how dim it looks from our planet. Such models are especially precise for stars like Polaris because the rate of their pulsing is directly related to their brightness. This makes it easy to figure out the distance to any of those stars. Astronomers trust this method so much that Cepheids have become an important tool for measuring distances all across the universe. At the same time, there are other ways to study the North Star, and they don't agree with the stellar evolution models. Polaris is a so-called astrometric binary. It means you can see its companion going around it. It looks as if a circle is being drawn around the bigger star. To complete one orbit, the smaller star needs around 26 years. Even though astronomers haven't made detailed observations of Polaris B's full circuit, they've seen enough to know what its orbit looks like. Using this information, one can apply Newton's laws of gravity to calculate the masses of the two stars. Combined with the Hubble Space Telescope's new measurements, these calculations lead to very precise numbers. Polaris is supposed to be around 3.45 times the mass of the Sun, but that's much less than the mass you get from stellar evolution models. They suggest a value of almost 7 times the mass of the Sun. But there's another reason why this star system is weird. After calculating the ages of the stars, researchers concluded that Polaris B is much older than its bigger sibling, but it's extremely unusual for a binary system. Normally, both stars are of the same age. One explanation might be that at least one of the measurements is simply wrong. After all, Polaris is a difficult star to study. Since it's positioned above our planet's North Pole, it's outside the field of view of most telescopes. As for those telescopes that do have the needed equipment for measuring the star's properties precisely, they're typically used for studying much more distant and fainter stars. Polaris is simply too bright for such instruments. It blinds them. There's a theory that the main star of the Polaris system was once two stars, but they collided a few million years ago. Such a binary collision could rejuvenate stars by pulling in extra material and making the stars look as if they went through the fountain of youth. It would also explain some other oddities, since stars that appear as a result of binary collisions don't fit stellar evolution models. Unfortunately, so far, none of the theories have been confirmed. The North Star is actually a big deal. Earth is spinning non-stop, which causes the sun to rise and set and stars to travel across the sky. Our planet is also tilted. That's why we have seasons. If we drew a line through the axis Earth spins around and extended it over 300 light-years past the North Pole, at the end of that imaginary line, there would be the North Star. It stays almost exactly at the same spot in the sky at all times and always points the way north. It's really important for navigation. People heavily relied on it in the days before GPS. If you were standing on the equator, Polaris would be right at the horizon. At the North Pole, it would seem to be right over your head. In other words, Using the star's height in the sky, you can not only figure out the needed direction, but also understand where you are on Earth. Curiously, there's no South Star. There isn't a bright enough star right above the South Pole, but one day we might get such a star. When you spin a top on the table, its end moves in a circle. We know this phenomenon as precession. Earth behaves in the same way, and the North and South poles won't always point towards the same spots in the sky. In the next 26,000 years, it may cause the North Star to change from Polaris to a few other stars, and back again. One day, the title of the North Star will go to Vega. It's the 5th brightest star in the night sky and the 2nd brightest in the northern celestial hemisphere. Vega has another name, Alpha Lyrae. That's because it's the main star of the Lyra constellation. Vega has been one of the most crucial stars to people since ancient times. It's very bright and blue, hence very recognizable. Vega was the North Star several thousand years ago, and it'll regain this status in 12,000 years or so. This star is located a mere 25 light-years from Earth. It's just 450 million years old, which makes it way younger than our own 4.6 billion-year-old star system. Astronomers study Vega to learn more about star systems in the early stages of their formation. Vega is almost directly overhead at mid-northern latitudes on a summer night. It hides behind the horizon for only 7 hours a day. You can see it on any night of the year. If you travel farther south, you'll find out that Vega lies below the horizon for longer periods of time. But in Alaska, northern Canada, and some parts of Europe, Vega never sets. Vega's blue-white light is bright enough to be featured a lot in ancient cultures, from the Chinese to the Polynesians to the Hindus. Vega's name can also be translated as falling or swooping. This is a reference to the times when people regarded this constellation as a swooping vulture, not a lyre. Vega was also the first star to get photographed, other than the Sun, of course. To do it, astronomers at Harvard College Observatory used a 15-inch refractor, and it happened again in 1850. Around 2 decades later, an amateur astronomer broke down Vega's light to reveal various elements making up the star. In 2006, thanks to telescopic observations, scientists found out that Vega was whipping around so fast that its poles were several thousand degrees warmer than its equator. The star rotates every 12.5 hours and is at 90% of its critical rotation speed. That's the velocity at which an object can tear itself apart. In 2013, researchers announced that they had discovered an asteroid belt around Vega. It means there might be planets somewhere out there among space rocks. There are 2 areas, an outer region that contains icy asteroids and an inner region with warmer space rocks. Scientists can examine bright stars like Vega using NASA's mission called TESS, which stands for Transiting Exoplanet Survey Satellite. It was launched in 2018 to conduct an all-sky survey. The main goal of this mission is to search for exoplanets, but the satellite can also look for star variability. By examining such stars as Vega, TESS can help scientists learn more about the early stages of star evolution.
Imagine a being so powerful it can suck in entire galaxies, so mysterious it's invisible to the naked eye, and so impressive it bends the very fabric of space and time to its will. Yes, meet my mother. Just kidding. Actually, meet the ultimate superhero of the universe, the black hole star. What is it and how does it work? Well, let's find out. The universe is full of marvels, and the black hole star is one of the most impressive ones. It's a supermassive force that can bend the laws of physics and a true enigma for scientists to unravel. No wonder science fiction writers find them so captivating. A black hole star, also known as a quasi-star, is a hypothetical type of extremely massive and luminous star that may have existed early in the history of the galaxy. They're predicted to be as luminous as a small galaxy, but unlike modern stars, they weren't powered by nuclear fusion in their cores. A quasi-star's energy would come from material falling into a black hole at its core. And yes, just like a normal black hole, these stars have the power to suck in anything and everything that gets too close, including stars, dust, and even entire galaxies. But how is it possible that the star is born from a black hole? And what's more, how do they continue to coexist together? Well, first let's discuss how black holes are born in general. It all starts with a supermassive star, one that is at least a few times more massive than our own Sun. This giant of a star burns bright and hot, shining with the light of 1,000,000 suns. But eventually, it runs out of fuel and its fate is sealed. As its lifespan comes to an end, it makes one final massive boom, a blast so powerful it can outshine an entire galaxy. This blast is called supernova. During this boom, the outer layers of the star fly away, while the core gets squished together by its own gravity. If the squished core is heavy enough, it can keep squishing until it becomes a black hole. And just like that, a black hole is born. Don't even try to put diapers on this thing. Now, this cosmic monster baby can continue to grow by swallowing up anything that comes too close, including stars, dust, and even entire galaxies. This is basically what's happening now in our universe with supermassive stars. But what about quasi-stars? The formation of a quasi-star could only happen early in the development of the universe, before hydrogen and helium were contaminated by heavier elements. And because of that, quasi-stars have one important feature. They are gigantic, so enormous that it's literally impossible to imagine. They may have been dwarfing even the largest known modern stars, like VY Canis Majoris and Stephenson 218. No wonder they're so scary. They were born from protostars, one of the first stars in the universe, the great-great-grandfathers of, everything. So now, imagine a protostar so massive that its core collapses into a black hole, just like we described before. But the key difference is that in a regular supernova, the outer layers of the star are blown away by the energy released during the boom. Meanwhile, in a quasi-star, these outer layers are massive enough to absorb the energy without being blown away. What do we get in the end? A star with a black hole in its core that weighs from 1,000 to 10,000 solar masses. This quasi-star is about 14,000 times bigger than our Sun, which makes them bigger than any star we know today. These celestial titans have some pretty crazy properties. Once a black hole is formed at the center of a giant protostar, it starts to give off a ton of energy. This energy helps to balance out the force of gravity, making it kind of a giant fusion-based star. They would be so bright that each one would look like a small galaxy. Quasi-stars would have a pretty short lifespan, around 7 million years. Just for comparison, our Sun is about 4.5 billion years old, and it's only halfway through its lifetime. But either way, during this short period, the black hole at the center would grow to be about 1,000 to 10,000 times the size of our Sun. Quasi-stars are also thought to be super hot, with temperatures reaching over 17,500 degrees. But as a quasi-star gets older, it starts to cool down, and its outer layers become see-through. Eventually, it cools down to a temperature of 6,740 degrees, and at that point, it's curtains for the quasi-star. It can't survive at that temperature, so it just dissipates, leaving behind an intermediate mass black hole. Unfortunately, right now, there's no observational evidence for the existence of quasi-stars. This is because they're thought to have only existed a very, very long time ago. They may have been very massive population 3 stars, which are extremely rare and difficult to detect. It's also very unlikely that any of them would still exist today because of their super short lifespan, only 7 million years. So why do scientists believe that quasi-stars could have existed? Because they're looking for ways to explain how supermassive black holes formed so early in the history of the universe. They're found at the center of most galaxies. But how could these monsters have formed so quickly? After all, it takes a really long time for small black holes to grow into supermassive ones. This is where the idea of quasi-stars come in. These stars aren't just destructive forces of nature. They're like the black belts in the martial art of gravity. They can bend and twist anything to its will. That's why these stars, if they really existed, had to play a crucial role in the evolution of galaxies. They must have been instrumental in shaping the universe as we know it. So those intermediate-sized black holes that they left behind could eventually turn into supermassive black holes in the center of galaxies. But we're still yet to solve this cosmic mystery. Detection and study of black hole stars is like trying to find a needle in a haystack. Only instead of a needle, it's an invisible and mysterious object. And instead of a haystack, it's the vast expanse of space. But with the help of some pretty cool technology and a lot of brainpower, scientists are getting closer to uncovering the secrets of these celestial giants. Here are some things that can help us in this research. First of all, gravitational waves. They're like ripples in the fabric of space-time, caused by the movement of massive objects. Albert Einstein predicted them way back in the 20th century, but they were finally detected only in 2015. We caught them by observing the collision of two black holes. This discovery confirmed that black holes can merge and that they're a powerful source of gravitational waves. Scientists think that by studying these waves, they can learn more about how black holes form and grow. We can also try to detect quasi-stars by observing the effects of their gravity on nearby objects. It's like trying to spot a criminal by their fingerprints. For example, if a black hole is located near a star, scientists can observe the star's light being distorted as it's pulled toward the black hole. And of course, we can use our technologies, such as X-ray, infrared, and radio telescopes. This allows us to study black holes in various ways and at different stages of their lives. In other words, scientists are working hard to uncover the secrets of these celestial giants. We develop new telescopes, search for primordial black holes, and try to understand the connection between black hole stars and dark matter. And we're making some pretty incredible discoveries, just like with gravitational waves. All these things will bring us closer to uncovering the secrets of quasi-stars. And when we find out the truth about them, it will become a new page in our scientific history. A space mission like this has never been done before. Nearly 20 years in the making. It's so precise that even a millimeter of error could ruin the whole thing. Two satellites are floating hundreds of miles above the Earth with one big goal: to create artificial solar eclipses on demand. This could change how we study the Sun forever. But pulling it off is insanely difficult. And let's just say, NASA and the ESA are holding their breath. Proba 3 has successfully launched and already shows promising results. It's made up of two satellites that will fly in perfect formation. Their goal is to block out the Sun in space. Well, why do we need that? Because solar eclipses are actually very useful for studying the Sun's corona, its glowing outer atmosphere. The Sun is obviously super bright, so its corona is only clearly visible during rare fleeting moments when the Moon perfectly covers the star during an eclipse. But what if we could recreate that effect anytime? That's Proba 3's main task. One satellite acts as an occulter, a giant sun-blocking disk. It also carries a wide disk about 5 feet wide, which acts like an artificial moon, blocking out the Sun's light. The other is a coronagraph. It should capture detailed images of the corona. There's also a third device that should study space weather and how solar storms affect our planet. It's insane how perfectly precise they must be for this to work. They must stay perfectly aligned with their position shifting by no more than a single millimeter, about the thickness of a fingernail, all while they're floating high away from Earth in space with no strings attached. This project was a team effort and a pretty big historical moment. This is the first time that an ESA mission is launched from India since 2001. Proba 3 was built with contributions from 13 European countries, along with Canada. There was a small hiccup before departure, though. The air freight company refused to accept the satellites because their batteries were still inside. The engineers had to remove the batteries and ship them separately. Not ideal, but a small price to pay for getting the mission to the launch pad. The idea first came to mind in 2005 to ESA scientists, and after years of planning, designing, and testing, the mission finally lifted off on December 5, 2024. For the first few weeks after launch, the two satellites stayed connected. Scientists run tests to ensure they were functioning properly. During this time, the coronagraph took its first-ever space image. It captured a beautiful star field in the Ophiuchus constellation. Then, on January 14, 2025, the real mission began. The two spacecraft successfully separated from each other. Over the following weeks, ESA's engineers carefully brought them back together to keep controlled distance. Now that they're in orbit, Proba 3 satellites work in a highly elliptical orbit, swinging between 372 and about 37,000 miles from Earth. This should help ease the Earth's gravitation, meaning the satellites won't need to burn as much fuel to stay perfectly aligned. The spacecraft also communicate with each other using lasers, adjusting their distances in real time. This level of control has never been attempted on this scale before. But the Proba 3 mission isn't only about looking at the Sun. The second satellite, the Occulter, has its own mission. It carries DARA, an instrument that will measure the Sun's total energy output. This is incredibly important for climate studies. Scientists need to know how much solar energy reaches Earth. If Proba 3 succeeds, it'll prove that satellites can fly in space autonomously while staying super precise. This could open the door to entirely new types of space missions. For example, giant telescopes in space, where separate satellites act as one enormous lens. Or more advanced climate monitoring with precision instruments orbiting Earth together. Finally, deep space exploration. Spacecraft could team up to explore planets and moons in ways never seen before. 2025 is going to be full of insane space missions. It's packed with lunar landings, asteroid visits, and planetary flybys. But space is never easy. Missions get delayed, some never launch, and others surprise us. First, IMAP, Interstellar Mapping and Acceleration Probe. This one will launch in September, and it should help us unlock the secrets of interstellar space. It will travel super far away to study the boundary between our solar system and interstellar space. This mission will help us learn more about cosmic rays, solar winds, and what happens when the Sun's influence stops and the actual terrifying space begins. Next, PUNCH and SPHEREX. These two were already launched on March 11, 2025. PUNCH will help predict solar storms before they hit Earth. It will track solar winds from the Sun to Earth and help us understand space weather better. Space weather is important because it can damage satellites and power grids. And SPHEREX will map the entire sky in infrared light, capturing the spectra of millions of galaxies. It could reveal the secrets of how galaxies formed after the Big Bang. Next, we've got TON2, which should launch sometime in May. It will visit the legendary asteroid Kamao'aliwa. Many years ago, this asteroid might have been a chunk of the Moon, and now it orbits the Sun. The next one is ESCAPADE. Once again, two spacecraft, one Mars mission. ESCAPADE should be launched somewhere during 2025. It will send two small spacecraft to Mars to study how the solar winds influence our red buddy. Many years ago, Mars used to be like early Earth. It had a thick atmosphere and liquid water, but it's now a dry, cold desert. ESCAPADE will help us understand what exactly happened. How and why did Mars lose its atmosphere? 2025 will also be packed with lunar missions. Unfortunately, not all missions are going to be successful. For example, the IM-2 lunar lander reached the Moon's surface on March 6th. It was supposed to land near the Moon's south pole to search for water ice. Finding water on the Moon would be incredibly important for our future human missions. If we find a method to turn this water ice into normal water, we'll be able to build entire settlements there. Well, IM-2 was marched on February 27th. It traveled to the Moon successfully and prepared for landing. It made it to the surface, but something went wrong. Communication was lost temporarily, and no one really knew why. When NASA re-established contact, they saw that the lander wasn't in the correct position. One of its two radio antennas wasn't working. Turns out it landed sideways, and now solar panels can't generate enough power. And without power, the lander couldn't keep working. By March 7th, the battery was completely drained and the mission was over. But there are more plans. In late 2025, they should launch the Griffin lunar lander. The rover it will bring should explore the Nobile crater, a key target for future moon bases. In somewhere between 2025 and 2026, they want to try the IM-3 lunar mission. It's going to be a third lander with multiple science experiments. Now, what about the planets? NASA's Europa Clipper is currently headed to Jupiter's icy moon Europa. Scientists have suspicions that this place could have water. It might even become a place for future human missions. On March 1st, Europa Clipper flew by Mars and used its gravity to speed up. On August 31st, ESA's JUICE spacecraft, another one that aims at Jupiter's icy moons, will fly by Venus. They might even snap some pretty pictures along the way. Finally, Juno's mission nears its end. Since 2016, NASA's Juno spacecraft has been orbiting Jupiter. It gave us breathtaking images and crucial data. Now, it's running out of time. If all goes as planned, Juno will continue until September before being deliberately crashed into Jupiter to avoid contaminating its moons. All these missions are pushing the boundaries of human knowledge, and we're just getting started.
Most of those twinkling dots scattered across the night sky seem unreachable. But one of them is Betelgeuse, a star so enormous and nearby that you can see it with the naked eye. To find it, locate the first 3 big dots in the Orion's belt. A reddish star to the left is Betelgeuse. It's one of the brightest stars we can see from Earth. And it's just 640 light-years away. No big deal. Betelgeuse has a blue-white O-type star, which is one of the hottest types to exist. Betelgeuse was scorching hot, reaching temperatures of about 90,000 degrees Fahrenheit. Although that was back in the day, now it's an elderly star and it cooled down to just 5,800 degrees. You know, vacation weather. Blue-white stars are absolutely massive and burn incredibly bright because they have loads of hydrogen fuel. But they have a price to pay for this glory. They burn through their fuel super quickly. As they age, they transform into red giants. This is exactly what happened to Betelgeuse. It burned through its hydrogen and started burning helium instead. This caused its outer layers to puff up like a balloon, turning it into a red supergiant and making it one of the largest stars out there. Now it's stretching over 700 million miles in diameter. Now it's about 1,000 times bigger than our Sun. If Betelgeuse replaced it, it would swallow up Mercury, Venus, Earth, Mars, even Jupiter. And its atmosphere would almost reach Saturn. But something strange has been going on. Betelgeuse spinning way faster than it should for a star of its size. Huge stars like Betelgeuse are expected to rotate slowly, but it suddenly started spinning at a rate of about 3 miles per second. Thanks to powerful radio telescopes, Betelgeuse's orange-red surface can be seen in detail. That's how we learned that it often changes its brightness. Sometimes Betelgeuse shines super brightly and then gets very dim. This happens about every 400 days. And recently, a telescope called ALMA, which is made up of many antennas working together as one, showed that Betelgeuse's surface seems to be moving unevenly. It's like one side is coming towards us while the other is moving away. But all of it might be a trick of light. Betelgeuse isn't as smooth as our Sun. Instead, it's super chunky. Its surface is like a boiling cauldron. It's bubbling and churning incredibly fiercely. Imagine giant plumes of hot gas erupting from its core, reaching the surface and then vanishing back inside. And these bubbles are bigger not only than the Sun, but Earth's entire orbit around the Sun. These bubbles also rise and fall super quickly, even faster than a spacecraft. And maybe this tricks our telescopes into seeing it spin faster than it really does. Some astronomers also think that Betelgeuse could have swallowed up another star, and this gave it a spin boost. But these are all just theories. Things got even more complicated when Betelgeuse dimmed once again, this time in a pretty unexpected way. What's interesting, it was discovered using a weather satellite. A regular telescope had a hard time seeing Betelgeuse clearly because of Earth's atmosphere. So they used a satellite that normally watches Earth's weather, but can also take pictures of space. As we mentioned, it usually brightens and dims about every 400 days. But recently, it suddenly dimmed by 2.5 times more than ever before. This event got the name the Great Dimming. The first theory said that Betelgeuse cooled down and sneezed out a bunch of material, creating a massive dust cloud. This cloud blocked the view of the star, making it look much fainter than usual. They also noticed something strange happening to that dust. It started behaving differently, which might be a sign that something deep inside the star was causing trouble. Betelgeuse's brightening and dimming cycle now happens faster in just 200 days instead of 400. And to add to the mystery, in the spring of 2023, it started shining even brighter than it normally does at its peak. Why is this frightening? Because Betelgeuse might be preparing for its grand finale, and this wouldn't be very good for Earth. We might be on the verge of a supernova. When massive stars like Betelgeuse run out of fuel in their cores, they start burning different elements like carbon, oxygen, and silicon. Eventually, they end up with iron in their cores. At that moment, everything changes. Adding helium to iron doesn't produce energy like other reactions do. Instead, it sucks up energy. This causes the star's core to collapse, leading to what's called a core collapse supernova. A spectacular, breathtaking show. Supernovas are so bright that they can outshine entire galaxies. But a Betelgeuse supernova would be special. Because it's relatively close to us, it would be so bright that we could see it even during the day. When it happens, Betelgeuse will shine as brightly as a full moon, but all that light will be concentrated in one point. For about 2 months, it will be so bright that you could read a book just from the light of the supernova, even if you turned off all the city lights and had a clear sky. The idea of witnessing Betelgeuse explode as a supernova is truly thrilling. After all, the last time a star went supernova in our galaxy was way back in the time of Johannes Kepler, more than 4 centuries ago. That event, known as the SN 1604 or Kepler supernova, dazzled the sky for weeks. But don't get too excited yet. We're not sure when exactly it'll happen. One study says that the star might be in its carbon-burning phase. If we're near the end of that stage, then Betelgeuse might blow up very soon, during the next tens of years. But it's nearly impossible to determine because during that last phase, the star barely changes at all. Even though Betelgeuse is close enough for us to study its surface, we can't peek inside its core to see what's really happening with it. We might as well be at the beginning of the carbon-burning phase, and in that case, we might have to wait 1,000 more years before that cool supernova. Another study says that Betelgeuse might have less than 300 years of fuel left in its core. They say that Betelgeuse is known to expand and contract regularly, and its pulsation pattern hints that Betelgeuse is much larger than we previously thought. This would suggest that the star is further along in its life cycle and closer to going supernova. Other guesses come from observations of similar stars. For example, a star called VYCMA in our galaxy is thought to be closer to going supernova than Betelgeuse, and it's been dimming steadily over the past century, unlike the relatively stable Betelgeuse. If Betelgeuse was about to go supernova, it would dim steadily and very quickly. Also, historical records suggest that about 2,000 years ago, people saw Betelgeuse as yellow, not red. If that's the case, then we might be in its early last days after all. In other words, we have no idea whether it will go supernova tomorrow or in 1,000 years. We just gotta wait and see. But let's say it goes supernova tomorrow. What happens to us then? The 1987 supernova in the Large Magellanic Cloud showed that the effects from the supernova might be so strong we can sense it even from very far distances. The Large Magellanic Cloud is almost 170,000 light-years away, and we still detected the radiation. It's kinda hard to say exactly what the danger zone is. A rough estimate could be around 100 light-years. Luckily, Betelgeuse won't pose any danger to humans. It's hundreds of light-years away, and its supernova won't influence us in any way. We'll be able to enjoy its supernova beauty without any harm.
Hop on board. Hurry, we don't have much time. We're on a cosmic journey to find the biggest star in the universe. The first star we pass is our own sun. By far, not the biggest one out there, but it's still massive. You could fit 1 million Earths inside it. That means if you think of the sun like a basketball, Earth would be half the size of a pencil eraser. If we put all the planets on one side of a scale and the sun on the other, the planets wouldn't stand a chance. The sun makes up 99.9% of all the mass in the entire solar system. Mass is basically how much stuff or matter something is made from, and it's what you can thank for stars shining. You see, the more matter in a star, the thicker and hotter its core becomes. This starts a chain of chemical reactions. Hydrogen atoms get smashed into each other to form helium, releasing an incredible amount of energy. That's the star's light and heat. So, bigger stars also equal brighter ones. But with all those reactions going on, this shortens a star's lifespan. When it starts to run out of fuel, the star will enter the giant phase. It'll expand and turn red. Which brings us back to the task at hand. The biggest star we'll find is likely to be on the edge of its life. Switching on our hyper light engines, we soon arrive at the Lumen 16 system. Here, we'll find one of the smallest stars out there, a brown dwarf. Small here means about the size of Jupiter, but they're small for stars. Brown dwarfs are also called failed stars because they don't have enough mass for those chemical reactions. That means they're not as bright, but they're super dense. All the matter in them is packed together so tightly, they weigh 80 times more than Jupiter, even being the same size. And if you think that's something, just look at a white dwarf, even more tightly packed. This one here is Sirius B. It's also about the size of Jupiter, but it'd weigh as much as the sun. It emits a dim white light. Once it runs out of gas, it'll turn red and cool down. Now let's fly closer to its giant neighbor, Sirius A. You easily see this star from Earth. No telescope needed. Twice heavier and more than 1.5 times wider than our sun, it's the brightest star in our night sky. Now we fly 550 light-years away from Earth to the constellation Cassiopeia. Almost 100 years ago, a cosmic explosion happened here. It expanded the atmosphere of the star Gamma Cassiopeia, and some gases were thrown into space. After that, it became the brightest star in the constellation. It's 10 times wider than our sun. On to the famous North Star. Funny enough, different stars have had this title over the years, and more will take it in the future. That's because Earth's pole star changes every 26,000 years. Imagine our planet like a spinning top. The northern pole will shift around in a little circle, pointing at different stars to the true north. The current one is a supergiant 37 times wider and 5 times heavier than our sun. It's easy to find in the night sky. It's on the very tip of the Little Dipper's handle. Get ready now. We're setting off for the eye of the storm, the center of our Milky Way galaxy. To see the next star, we need to switch to infrared mode. This pistol star is hiding from us in space dust. In just 20 seconds, it emits as much light as our home star does in an entire year. And its size is jaw-dropping. It's 420 times wider than the sun. But it's still not the most luminous star known to humanity. That would be a blue supergiant in the constellation Triangulum. Meet B416. It's almost 10 million times brighter than the sun. But the brighter a star, the faster it burns up all its fuel, and the shorter its life. Compared with a red dwarf that barely glows and burns fuel much more slowly, its life will be hundreds of thousands of times shorter. 3,400 light-years from Earth, there's one of the rarest celestial bodies in the universe. It's a yellow hypergiant called Rho Cassiopeia. Among the countless stars in our galaxy, there are only a couple dozen of these. And even though this star is extremely far away from our planet, you can still see it in the sky without needing a telescope. That's because it's 300,000 times brighter than our Sun. It also helps that the thing is 900 times wider than our home star, too. And its color tells us that its fuel reserves will last for a long time. When Rho Cassiopeia starts to turn red and expand, it'll be one of the biggest stars in the entire universe. Now, we move to the constellation Orion. The star is in our sights. Betelgeuse, one of the largest ones visible to the unaided eye. 700 times the size of our Sun. If it took our star's place, its surface would touch the asteroid belt. That's between the orbits of Jupiter and Mars. It would engulf the 4 inner planets, Earth included. But this star has astronomers very excited. They predict Betelgeuse will explode in a fantastic celestial show in the next 10,000 years. It'll be the greatest astronomical event of all time because we'll be able to observe a supernova at a close but safe enough distance. The exploding star will shine as bright as a half moon. It'll be visible in the daytime sky for a year and at night for several more. Now we venture to stars that exceed the Sun's width 1,000 times. Mu Cephei is a hypergiant boasting the title of the reddest known star. Its color tells us that the fuel gauge is getting closer and closer to empty, but it's still so big that it could hold 1 billion suns in it. And because of its mass, this star will eventually become a supernova or even a black hole. Let's take a trip of almost 4,000 light-years from home. Here it is, a red supergiant called VY Canis Majoris. It's one of the biggest and brightest stars of the Milky Way. It could fit 3 billion suns. And even though it's so huge, this thing is surprisingly light, only 17 weights of the Sun. In the context of celestial bodies, you could call this star an inflated balloon. In the next 100,000 years, VY Canis Majoris will explode in a hypernova. Gamma radiation will destroy all life in the local part of the universe. But this star is so far from our solar system that it wouldn't mean any harm to us. If we placed MY Cephei in the center of our solar system, it would bulge all the way out to Saturn's orbit. To remind you just how far away Saturn is, think of it this way. It takes the Sun's light 8 minutes to reach Earth. To get to Saturn, it takes well over an hour. Compared to this massive star, the Sun is just a grain of sand. It's one of the most luminous and reddest stars in our universe. The bigger and redder the star, the closer it is to its end. So, we're not looking at just a titan of the universe, but also one of the oldest celestial bodies out there. The second biggest star in the universe is UY Scuti. It's about 1.5 billion miles wide, 16 times the distance from the Earth to the Sun. This is a pulsating variable star. Its brightness changes about every 2 years. UY Scuti is a record breaker in fuel combustion per year. Scientists expect it to evolve back to hotter temperatures like a yellow giant. Our journey is coming to an end. Before us, we behold Stephenson 218. It takes 20,000 years for light from this star to reach Earth. It's hard not to see this red supergiant on our tiny terrestrial home. It's 2,150 times wider than our Sun. We'd need 10 billion suns to fill its volume. For comparison, the average beach contains only about 5 billion grains of sand.
This planet, yeah, the one right here, shouldn't exist, but it does. A newly discovered planet rotates around a star that's much smaller and dimmer than our Sun. The planet, however, is enormous. Such a tiny star couldn't create it, so it's like finding an ostrich egg in a chicken coop. A team at Penn State built a special tool called the Habitable Zone Planet Finder. It's an instrument that's supposed to find planets around dim, cool stars. It's connected to a big telescope in Texas. The tool looks at the light from these stars, which is mostly in the near-infrared, beyond what our eyes can see. This gadget can spot changes in a star's speed caused by a planet. If the star movement slightly changes, that means there must be a gravitational pull nearby. Years ago, this technique helped find the first known exoplanet around a star like our Sun. Today, we've improved this method to make more precise measurements. Our main goal is to find Earth-like planets. They should be rocky and located in habitable zones, areas around stars where liquid water could exist. The Doppler technique isn't that great at finding Earth-like worlds yet, but works well for cool, dim stars. And that's how we discovered the impossible LHS 3154b. Planets usually form in disks made of gas and dust in space. Picture a flat, spinning cloud of tiny particles. These particles come together and stick to each other, creating a flat, rotating disk. Over time, these tiny bits combine to form a solid core. This is the starting point for a planet. Once the core is there, it attracts more dust and even gas like hydrogen and helium. But making a planet this way isn't easy. They need a lot of stuff, mass, and materials. This process is called core accretion. Stars are a huge help in that process. Usually, big stars have more gravity, so they can gather more stuff to form planets. But the star we discovered recently isn't very big. It's 9 times smaller than our Sun. A star this small shouldn't have a big enough disk to make a heavy planet. To do that, its disk should have been at least 10 times bigger. But this heavy planet, LHS 3154b, exists. Now, this mysterious planet is 13 times heavier than our Earth. It's similar in size to Neptune. It's about 50 light-years away from us in the Hercules constellation, which, in space terms, is very close. The planet is also super close to its star, completing 1 year in almost 4 days. This discovery is making scientists rethink their ideas about how planets and stars come into existence. There are new theories coming around. For example, a theory called gravitational instability. It says that, instead of the pieces coming together bit by bit, the material in the disk collapses all at once, directly creating a planet. But even with this theory, it's hard to explain how such a heavy planet could form without a really massive disk. It'll take us some time to figure out the truth. This isn't the first planet that makes us doubt our theories. Recently, scientists found another planet called Hala. This planet is orbiting a star called Betelgeuse, and just like the previous one, it shouldn't really exist. It's way too close to its star. Stars change a lot during their lives. Normally, when a star becomes big and prepares to leave this world, it's called the red giant stage. A star like that tends to destroy or push away any nearby planets, creating a huge mess. Hala rotates around a red giant, and it should have been swallowed or destroyed by the expanding star a long time ago. But it's still hanging there. Even though Betelgeuse has already started burning helium and shrunk to a smaller size than expected, Hala isn't bothered in the slightest. Scientists call Hala the Forbidden Planet. This discovery challenges what we thought about how planets survive near aging stars. It raises 2 theories. One suggests that Betelgeuse was once 2 stars, a white dwarf and a red giant. Hala orbited them both, and they merged before the red giant fully expanded. This allowed Hala to survive because the extra helium from the white dwarf prevented the red giant from growing too much. The second theory says that Hala formed from the debris created when the 2 stars merged. In this scenario, Hala would be a very young planet orbiting an elderly star. Astronomers plan to continue studying Hala and look for more planets like that. Another oddball, besides me, is called LTT 9779b. This one scares us too because it's too shiny. The planet reflects 80% of the light from its star. Regular mirrors reflect from 85 to almost 100% of light, which means that this mysterious planet should look like a rough mirror, with aluminum or silver-like reflections. This is another Neptune-sized planet. It's located 268 light-years from us and was discovered by NASA's TESS spacecraft. It completes a full rotation around its star in just 19 hours. It's so close to its star that it's scorching hot, reaching temperatures over 3,600 degrees Fahrenheit. Normally, planets this close lose their atmosphere and turn into bare rocks. But this one breaks the rules again. Now this time, we know the secret of its survival. It's because of the planet's shiny metallic clouds, which are made of glass and titanium salt. These clouds rain titanium onto its hot surface. They also reflect a lot of the light, preventing the planet from getting too hot and losing its atmosphere. It's like having a mirror shield. This planet's size also surprised scientists. It's way bigger than Earth. Other planets this close to their stars are either much bigger gas giants or small rocky planets. This planet is a smaller gas giant, and scientists didn't expect it to exist so close to its star. This is the shiniest planet ever found, even shinier than Venus. But despite its cool appearance, it's probably not a friendly place for life because of its extreme temperatures and strange metallic rain. And our final rule breaker is a planet called WASP 107b. Scientists discovered it using the James Webb Space Telescope. It's located around 208 light-years from us in the Virgo constellation. It's also fast and completes an orbit around its star in just 6 days. This is a super-Neptune exoplanet. It's similar to Jupiter in some ways, including the same size and scorching hot temperatures. But the main difference is that it's much lighter, weaker, and less dense. This is the least dense planet we've discovered so far. After researching some more, we also found that it has a tail. The helium on the planet extends beyond the transit egress. The planet is slowly losing its atmosphere due to extreme ultraviolet radiation from the star. This creates a comet-like tail. So, it looks like a fluffy comet. But that was just the beginning. The planet's low density, or fluffiness, allowed astronomers to study its atmosphere in detail. They found some surprising things, like water vapor and clouds made of fine silicate particles, which are like really fine-grained sand. The planet's host star doesn't emit a lot of high-energy light. But since WASP 107b is so loose, the light can penetrate deep into its atmosphere. This creates sulfur dioxide that smell when you light a match. In other words, it's a fluffy planet that rains sand and smells like matches. The researchers think the sand clouds in the atmosphere form in a similar way to clouds on Earth. They just have droplets of sand instead of water. These sand droplets condense, fall, turn into silicate vapor in hot layers within the planet, and then rise again to form clouds once more. And, once again, this planet couldn't have formed in its current spot. Astronomers say that it likely moved closer to its star from a birth orbit because it was attracted by some heavier neighbor. It also follows a retrograde orbit, meaning it orbits in the opposite direction to its star's rotation. All these discoveries are changing how we understand planets and their atmospheres, giving us new insights into the mysteries of our own solar system.
Stars are beautiful, colorful things. There are red giants. Those are nearing the end of their lives and are on the verge of explosions. Blue stars shine in the belt of the constellation Orion, as well as other places. Yellow ones, like our sun, are pretty ordinary. They're usually warm and stable enough to support life. But look at the night sky attentively. Do you see any green or purple stars? Nope. They're kinda invisible because of the way we humans perceive visible light. The color of a star mostly depends on its surface temperature. The hotter it is, the shorter wavelengths the light it emits will have. The hottest stars are blue or white blue. Those are some of the shortest wavelengths of light. Cooler stars are normally red and red-brown, which are longer wavelengths. At the same time, stars never send out their light in just one wavelength. It's more of a range of light. The wavelengths of light from a star peak in just one color in a bell-shaped curve. But the star emits other colors too. Human eyes have evolved to see yellow and green radiation, probably because our sun emits it mainly in these wavelengths. But a green star emits radiation right in the center of the visible light spectrum, in all possible colors. That's why such stars appear white, which is a combination of all hues. Actually, our sun emits quite a lot of green light, but we perceive it as white. Purple stars, though, are something our eyes won't ever see because they're sensitive to blue light. And since stars emitting purple light send out a lot of blue light too, because these shades are next to each other on the visible light spectrum. The human eye picks up only the blue light. When it comes to other objects in the solar system, many planets seem to have no obvious hue. Look at Venus, Saturn, or Jupiter. They look kinda bland, probably whitish at best, but there are several planets that boast very decisive colors. For example, Mars looks orange-red, Neptune is blue, and Uranus has a beautiful blue-green hue. The planet gets it from all that methane gas in its atmosphere. Meteors sometimes display a vivid green too, and look at breathtaking bright auroras. Green is the most common color of the northern lights. But not stars, never stars. The brightest star in the sky, besides our sun of course, is Sirius. It's twice as bright as its competitor, Canopus, located in the southern constellation Carina. Being the most brilliant, Sirius is very easy to identify. Probably the coolest thing about this star is that it seems to be changing its color. But we'll get to it a bit later. This star is whiter and hotter than the sun. Its surface temperature is 17,300 degrees F, while the sun's surface temperature only reaches 10,000 degrees F. When you combine the immense heat Sirius emits with its girth, 1.75 times the size of the sun, you'll understand why the star looks so bright in the night sky. Sirius has a companion star. It's called the Pup. It's a tiny but incredibly dense white dwarf with a diameter of a mere 7,000 miles. This makes it smaller than Earth. At the same time, its mass reaches 98% of that of the Sun. It means that the matter inside this tiny star is squeezed very, very tightly. That's why its gravitational pull is 350,000 times greater than Earth's. A person weighing 150 pounds would weigh 50 million pounds on this star. Now, Sirius is famous for its twinkling, and since it is also the brightest star, we can observe the ever-present turbulence in its atmosphere quite well. As for the star changing its color, it has to do with the atmosphere of our planet. Pockets of air at different temperatures focus starlight this way and that like small lenses. We see it as twinkling. But since white light is made of different colors, one pocket might send some red our way. Another will send blue or yellow in totally random order. That's why it seems that Sirius twinkles in color.
Castles were cold places in times past. The stone seemed to radiate the winter chill. This is one practical reason why tapestries were hung upon castle walls, to help keep the cold out and the warmth in. But you just can't hang any old thing on castle walls. It should be beautiful, heroic, with a heavy wow factor. The ancient Greeks hung tapestries on the walls of their castle of the sky, glorious tapestries woven of stars. All 48 constellations of the Northern Hemisphere were designed and named by the Greeks. The story of Andromeda is one such tapestry, woven of 7 constellations spread across the entire autumn sky. The story contains detailed astronomical observations preserved as highlights in the sky tapestry. It begins with the constellation Cassiopeia, queen of the oldest realm in Africa, Ethiopia. When the constellation Cassiopeia is on the horizon, it looks like a staircase going up to the Milky Way. Step pyramids around the world are often thought to have been inspired by the constellation Cassiopeia. In any case, Cassiopeia is a beautiful constellation, indicating that Queen Cassiopeia was also a beautiful woman. She was good-looking, but equally vain, which sets off all the dramatic action. Cassiopeia can be found in the night sky opposite Ursa Major from the North Star. Like Ursa Major, Cassiopeia circles the North Star and is a circumpolar constellation. A supernova was observed in Cassiopeia around 1680 Earth time. Cassiopeia A having occurred about 11,000 years earlier. The Chandra X-ray satellite recently recorded an extraordinary photograph of this supernova remnant showing the elements sulfur, calcium, silicon, and iron amid the expanding cloud's high-intensity X-rays. Cassiopeia's husband is also a circumpolar constellation, a minor dim one named Cepheus. He had his own kingdom. A merger of empires by way of marriage is something common throughout history. Cepheus was a king of Phoenicia. There were many kings of Phoenicia back in the days when Phoenicia was just a collection of city-states along the western shore of the Mediterranean Sea. Cepheus can be found in the area between Cassiopeia and the North Star. The constellation of Cepheus is important to astronomers. It's where Henrietta Swan Leavitt discovered variable stars that pulsed at regular intervals. The rate of pulsation of the star indicates the true brightness of the star and enables a sure measurement of the distance to the star. The discovery of Cepheid variable stars was a major breakthrough for early 20th century astronomy. Cepheus and Cassiopeia had a daughter, Andromeda, also a noted beauty, about whom all the fuss is. It seems that one day Cassiopeia was boasting about the beauty of her and her daughter Andromeda. "We are more beautiful than any other women in the whole wide world." Well, such pretension can be forgiven for a queen. But then Cassiopeia went further and stepped beyond all natural bounds. In fact, "We are more beautiful than any of the Nereids." Well, the Nereids were Greek mythological sea nymphs, daughters of the ocean. Noted for their beauty and kindness to sailors, the Nereids, all 50 of them, took offense at being dissed by a mere mortal woman. Cassiopeia had to be punished for exceeding the bounds of the civil order. By her excessive vanity, Cassiopeia transgressed beyond the bounds of nature, for which an unnatural punishment was inflicted upon the entire kingdom of Ethiopia. A monster from the bottom of the ocean, the constellation Cetus, began to devastate the coastal villages of Ethiopia as well as Ethiopia's fishing ships. Fittingly, Cetus is a constellation of the southern celestial hemisphere. The fourth largest by area of all the constellations, Cetus swims in a dark part of the sky called the ocean, with only its head rising above the celestial equator. This part of the sky contains several water-themed constellations: Pisces, the fishes, Aquarius, the water-bearer, and Eridanus, the river. Over 50 exoplanets have been discovered in Cetus. You can bet the James Webb Space Telescope will have a field day analyzing the spectra of these planets' atmospheres, looking for signs of life. Meanwhile, Queen Cassiopeia and King Cepheus must do something about the monster devastating the shores of Ethiopia. They consult an oracle and make another trespass beyond the realm of reason and nature. "Tell us, oracle, what can we do to stop the monster from ravaging our kingdom?" This monster is not a normal affliction of nature. An offense was committed against the higher realms, and this is the punishment. The monster cannot be stopped by any normal means. Only a human sacrifice of the noblest being may placate the beast. One error compounds another. The noblest person in the kingdom, of course, is Princess Andromeda. According to the command of her father and the consent, or perhaps a suggestion of her mother, Andromeda is chained to a rock offshore. She is the human sacrifice that her parents hope will save the kingdom. Wow. Da-da-da-da! Here comes the Greek hero to save the day, stop the human sacrifice, and turn Cetus to stone. Perseus. Now, where is Perseus coming from? According to legend, the Hebrides. Perseus went to the Hebrides in pursuit of the Gorgon Medusa. The geological scope of this tapestry is incredible, from the Hebrides to the Red Sea. The Hebrides are an archipelago of mostly rocky islands off the western coast of Scotland. It was impossible to sail any further. The Hebrides were the absolute end of the world. Perseus didn't have to sail to the Hebrides. However, he flew on a pair of winged sandals. Hey, way to go, Perseus! Now, Medusa was one of the all-time baddies. One look at Medusa was so terrifying it would petrify you, literally turn you to stone. Perseus was in great danger. So, what did our hero do? Instead of looking at Medusa, Perseus used the scientific principle of reflection. He slew Medusa by seeing her reflected in his polished shield. In our sky tapestry, Perseus is portrayed holding up the severed head of Medusa. In the night sky, one eye in Medusa's head opens and closes and opens again. Arabic astronomers named the star Algol, the ghoul. Algol is an eclipsing double star. One star is bright, the other one, not that much. As the dimmer star orbits the bright star, it passes in front of the bright star, eclipsing it, and the eye closes. Since the dim star takes 2 days, 20 hours, and 49 minutes to orbit the bright star, The eye in Medusa's head opens every day and a half or so. The constellation of Perseus is immediately below Cassiopeia, and sky watchers quickly look to see if Algol is eclipsed, if Medusa's eye is open or closed. Perseus flew back from the Hebrides, accompanied by Pegasus, the winged horse. The central part of Pegasus is the Great Square, made up of 4 stars. As Earth goes around the Sun, the Great Square is right in the center of the night sky in autumn. In the summer triangle of Vega, Deneb, and Altair are in the middle of the night sky. In spring, it's Leo the lion, and in winter, it's Orion the hunter. These are the walls of the castle in the sky, and all have marvelous tapestries adorning them. The constellation of Andromeda shares a star named Alpheratz with Pegasus. It's one of the corners of the Great Square, so it appears Andromeda may be riding on Pegasus. Her crown, remember she is a princess, is floating nearby. M31, the Andromeda Galaxy. To see M31, cross the corners of the Great Square from the lowest star to the uppermost star, and then go a little further to see the Andromeda Galaxy. Be sure to peek at it from the corner of your eyes. It's called averted vision. The corners of your eyes are more sensitive to light, so you'll be able to see the huge spiral galaxy 2.5 million light-years away as a smudge of light 1.5 times wider than the full moon. Now, Perseus doesn't go in for human sacrifice, so he stops it and saves Andromeda by exposing Cetus to Medusa's gaze. And here we encounter the second eclipsing variable in our sky tapestry, Mira, the heart star of Cetus, the sea monster. Mira, from which we get the English word mirror, so fitting in a story about vain beauty, is an eclipsing double star. The dim star orbiting the bright star is a white dwarf, not bright enough to see with the unaided eye. The effect is that Cetus's heart shuts off. Mira is eclipsed and disappears. This cycle repeats itself every 332 days. Our fabulous star tapestry has the only 2 eclipsing binary stars visible to unaided eyes, the nearest spiral galaxy, and a hero that doesn't like human sacrifice and uses the scientific principle of reflection to thwart mythological monsters. Wow, I would hang that in my castle too. Just saying.
What would it be like to live on a planet traveling around a star so huge that, in comparison to it, our sun looks like a tiny speck of dust? Well, you could find it out if you manage to visit a planet orbiting WOH G64. It's a red supergiant, an enormous star dwelling in the Large Magellanic Cloud, which is a satellite galaxy located not too far away from our home Milky Way galaxy. Red supergiants in the Large and Small Magellanic Clouds provide an excellent opportunity to observationally test the current stellar evolution theory for massive stars. WOH G64 is likely the largest star we have found so far. It's a real heavyweight emitting an incredibly bright light. To understand the sheer size of this mega star better, let's put it into perspective. Compared to our star, the radius of WOH G64 is around 1,540 times bigger. In other words, it's like comparing a tiny grain of sand to a basketball. If we placed WOH G64 at the center of the solar system, the surface of this star would extend past the orbit of Jupiter, swallowing up Mercury, Venus, Earth, Mars, and Jupiter itself. You see, the average radius of Jupiter's orbit is around 1,000 times the radius of the Sun. As for Saturn, the radius of its orbit is around 2,000 times the radius of the Sun. That's why WOH G64, with its average radius being 1,500 times the radius of the Sun, fits right in between. Oh, and if you spread out the star's dust envelope, it would cover a distance of about 1 light year, or 5.88 trillion miles. The star is not only ginormous, but also immensely bright. In fact, it's one of the most luminous stars we know of. Luminosity is the total amount of energy a star emits per unit of time. And the light, coming from WOH G64, is around 282,000 times brighter than the light from our Sun. But perhaps one of the most amazing features of WOH G64 is the dust envelope surrounding it. In 2007, astronomers, with the help of the Very Large Telescope, discovered that WOH G64 was surrounded by a torus-shaped cloud. It's so thick that to some extent it obscures the star. The dust envelope is made up of the material the star has expelled, and it contains between 3 to 9 times the mass of the Sun. The star we're talking about was discovered in the 1970s by Bengt Westerlund, Olander, and Hayden. That's where the WOH in the name of the star comes from. It's an abbreviation made up of the first letters of the discoverers' names. By the way, Westerlund also discovered another remarkable red supergiant, Westerlund 126. It was spotted in a massive star cluster called Westerlund 1 in the constellation of Ara. But back to WOH G64. Scientists have noted that this star lies very close to or even beyond the Hayashi limit. It is a theoretical constraint upon the maximum radius of a star for a given mass, a condition where the inward force of gravity is matched by the outward pressure of the gas. By now, the star WOH G64 has reached such an evolved state that it can no longer hold onto its atmosphere because of super low density, high radiation pressure, and relatively opaque products of thermonuclear fusion. That's why its average mass loss is among the highest known to us so far. It's unusually high even for a red supergiant. WOH G64 also shows an unexpected spectrum of nebular emissions. The hot gas is rich in nitrogen and has a radial velocity more positive than that of the star, which is quite an unusual phenomenon. The star might have a potential companion, an O-type main sequence star. If it turns out to be true, then WOH G64 will be classified as a binary star. At the same time, so far, there have been no confirmations of this theory, partly because the intervening dust clouds make the examination of the star very difficult. In any case, WOH G64 is absolutely fascinating, not only because of its huge size, but also because of its unbelievable luminosity and mysterious dust envelope. It's a great example of how unexpected and amazing our universe can get. Besides, such outstanding large stars are undoubtedly an important astronomical observation. The results of studies of such objects correct the restrictions on the properties of stars within the framework of modern models. For testing the applicability of models, the exceptions to the rules are most valuable.
Is it possible for a planet to have not one, not two, but many suns? Let's imagine what would happen to us if the sun suddenly decided to break into a bunch of small stars. During the search for Earth-like planets throughout the universe, scientists have discovered that systems of 2 or even 3 stars are not actually that rare. Many of them even have planets in their habitable zones. Almost half of these planets could contain life. Can't wait to ask these guys about the sunsets. Scientists even suggest that our sun wasn't always lonely. It could have had a companion star called Nemesis. They've noticed that mass extinctions on Earth occur every 27 million years. It's like a cycle. So they turned to the stars to find out what the reason might be. And then they assumed that it was a star that left our sun a long time ago, but it still affects us. Nemesis could be located about 1.5 light years from us. It may not sound like a lot, but it's actually almost 9 trillion miles. That's going to be a fun car trip, 50 million years long. Anyway, every time Nemesis passes its orbit, it can affect the Oort cloud. The Oort cloud is an area surrounding our solar system in which comets are formed. Its existence hasn't yet been proven, but scientists are pretty sure about it. So, comets form inside this cloud and then relocate to our solar system. Even being very far away, the second star in the system can have a great influence on it. But what about systems with 4 or even more stars? Is it even possible? Actually, yeah. But the more celestial bodies you add to the system, the more difficult it becomes. The orbits grow unstable. It's going to be as chaotic as can be. In stellar mechanics, it's called the 3-body problem. It says that it's very difficult to predict the orbits of bodies in such systems. In most cases, they turn out to be very random and unique. Isaac Newton was the first to have noticed it. He tried to apply his gravitational discoveries to the Earth, the Moon, and the Sun. He found himself with quite a struggle. It wasn't easy to understand how three stellar objects orbit so stably around each other. And that's just a planet and a satellite. How about including several stars? I wouldn't envy those who'll have to calculate all this. Oh, right, it's me. Anyway, we know that triple star systems are ridiculously chaotic. But what about systems with more stars? They're very, very rare. In 2021, NASA discovered a star system of as many as 6 stars. That's just crazy. Of course, there are no planets in it, but who knows? Maybe one day we'll find such a system too. In such worlds, the gravity dance is very complex. It takes very specific conditions to hold everything together. It's like walking on a tightrope over an abyss. With all this in mind, let's try to imagine what would happen if the sun suddenly turned into several small stars. Oh, we're going to need a very detailed simulation. No, probably even a dozen simulations to make this thing work, because otherwise, we'd only have a few options. Option 1. We divide the sun into 5 to 10 tiny suns. Now we'll scatter these guys not far from each other. They'll destroy our system in a couple of hours. Yeah. All star systems, including ours, are in constant motion across the universe, so they'll crash into each other almost immediately. This collision will lead to the creation of a supernova. Our system will turn into a beautiful, colorful nebula. For us, it will happen in just a couple of minutes. We won't even have time to feel anything. And all the planets in the X solar system will immediately turn into sparkling space dust. But it's not the best option for us, right? Let's see if it can go any other way. Option 2. Since they can't be located so close to each other, let's try to set them as far away as possible. And in this case, they'll just leave. Bye-bye. Their gravitational force is too weak to hold everything together. The little suns will simply leave the solar system, flying into space in random directions. After that, the rest of the planets will descend from their orbits, including poor little us, of course. We'll become a so-called rogue planet. At first, we won't even realize that the planet has gone out of orbit, and we won't have time to do anything before it gets incredibly cold. What a sad and poetic end. In general, none of these outcomes sounds very fun. Oh, alright, we still have the last option. Our main problem is that we make each of these little stars the same mass. But just take a look at all these multi-star systems that we've already discovered. You'll see that none of them look like a bunch of glowing balls together. Instead, there are a couple of large stars there, and the rest, the small ones, are orbiting around them. So how about 2 large stars and 2 small ones? What will the Earth look like then? Well, its orbit will become terribly unstable. We'll shake back and forth. Wouldn't recommend it, honestly. We know what this can lead to because, and that's just crazy, this has already happened to us once. Yes, about 70,000 years ago, a lone star visited our solar system. It was a red dwarf called Scholz. A red dwarf is a very small and cold star, if you count 14,000 degrees Fahrenheit as cold, of course. But it's considered the weakest and coldest type of star, so it probably didn't look that big and bright in the sky. At that time, our ancestors, Homo sapiens, were already there living their lives. And can you imagine? They saw another star in the sky approaching the sun. I wonder what that looked like. And then, Scholz bypassed the sun and flew somewhere further to surf space. You weren't expecting some kind of disaster, were you? If it had happened, you wouldn't have had a chance to watch this video right now. But from this story, we can see what happens to the Earth during such stellar events. At that time, a huge amount of volcanic activity unfolded on our planet. We also got some meteor showers that almost wiped us out. Our ancestors sure had it rough. Something similar will happen on our hypothetical planet with 4 suns, but on a much greater scale. Constant volcanic activity, earthquakes, and tsunamis. Brr. In addition, the length of a day will change, as well as the length of all seasons, and a year as a whole. they won't be stable anymore due to the regular changes in gravitation. In other words, you'll never know when to expect an annual winter or hot summer. And when we are precisely in the middle between two stars, there won't be any nights at all. They'll illuminate both parts of our planet, and we'll have to sleep in bright sunlight. And if you think this is a bad thing, keep in mind that we'll also be attacked by much more ultraviolet rays and solar winds because of our 4 suns. Their color will also change. They'll become red dwarfs, looking distinctly orange-scarlet in the sky. We'll also get many more solar eclipses, except instead of the moon, the sun would be eclipsed by another sun. It would probably just get a little darker. To be honest, it's unlikely that anything would survive on Earth after all this. I mean, it is possible, but please run 100 simulations yourself if you want to make sure. But theoretically, we could survive in a simple binary star system. For example, in one that consists of 2 stars close to each other. Each of them would have to be 2 times smaller than our sun. That would be the perfect scenario. And it's quite possible in the future. NASA is currently working on a plan to relocate our descendants to Proxima Centauri b. That's a planet near the closest star system to our sun, Alpha Centauri. And who knows, maybe one day in the future, we'll really move there. Then we'll see what it's like to live with several suns. A powerful burst of gamma radiation lasted a mere half-second, but it released an enormous amount of energy. It was more than our sun would produce in 10 billion years. This brief flash lit up the whole sky. Afterward, a much softer and more long-lasting glow replaced it. Astronomers examined the phenomenon with X-ray, radio, optical, and infrared waves. It turned out that people had finally seen a newborn magnetar for the first time ever. It was likely formed after 2 neutron stars had merged. It resulted in a kilonova, one of the brightest and largest stellar blasts. Its light finally reached our planet on May 22nd, 2020. Imagine a massive star, at least 5 times the mass of our sun, reaching the end of its life. It might be because it's run out of its nuclear fuel. If it happens, the star starts to cool off. The pressure inside drops, and the gravity starts to squeeze inward. And then, more than 1 million times the mass of our planet collapses within 15 seconds. It happens so fast that an enormous shock wave causes the outer part of the star to blow up. It produces a blinding burst of light. This powerful blast is called a supernova. What's left behind is an incredibly dense core with a huge cloud of hot gas, called a nebula, expanding around it. If the star has been massive enough, more than 10 times the size of the sun, it's likely to turn into a black hole. If not, it turns into a neutron star. It's basically a giant nucleus, the central part of an atom. These stars are mostly made up of neutrons and are rarely larger than 20 miles across. For comparison, our sun is almost 865,000 miles across, which is 109 Earths put side by side. But don't let this relatively tiny size fool you. Any neutron star is at least 1.5 times heavier than our sun and has an intense magnetic field. If you scooped just a teaspoon of this star's insides, this matter would weigh more than 1 billion tons. It's so dense that it makes neutron stars some of the most extreme objects people know about. The next stop is the black hole itself. When 2 neutron stars merge, they most often create a new, much heavier one. Within milliseconds, or even less, this star collapses into a black hole. But the astronomers who examined the flash of light recorded in March think there might be another outcome. They're almost sure they saw something never observed before: the birth of a magnetar. That's a rare form of a neutron star with an ultra-strong magnetic field. It's 1,000 trillion times stronger than our planet's. This field is also so powerful, it heats the star's surface up to 18 million degrees Fahrenheit. To put it simply, magnetars are the most powerful magnets in the universe. Their magnetic fields can seriously mess with the neighborhood. Atoms, unlucky enough to get close to such a star, get stretched into pencil-thin lines. If you somehow found yourself several hundred miles away from a magnetar, it would end badly for you. The magnetic field would first disrupt your bioelectricity. It means that your nerve impulses wouldn't work anymore. Even your molecules would change under the influence of the star's field. In the end, you'd pretty much vanish. If a Magnetar flew within 100,000 miles from our planet, it would wipe out all the data on every single credit card in the world.